Okay, in this tutorial I'm going to introduce the idea of ions. So what is an ion? Well, we've looked at electron configurations and looked at the idea that the electrons in an atom are arranged into these shells. And we've probably even mentioned the idea that atoms will often try to gain a full outer shell. And that's got to do with stability. An atom is more stable if it has a full outer shell. So atoms will either try to lose valence electrons or to gain valence electrons in order to fill their outermost shell. And once they've done so, once they have a full outer shell, they're more stable. So, however, if an atom loses electrons, or if it gains electrons, it won't have an equal number of positive and negative charges. So remember, it's the protons in the nucleus that are positive, and the electrons around the outside that are negative. And in a regular atom, we have an equal number of protons positive and electrons negative. However, if we add electrons to that or take electrons away, so if an atom gains or loses electrons, it's obviously going to have an overall charge. There's going to be an imbalance between the positive and negative charges. So that's basically what an ion is. An ion is a charged atom. So let's look at an example. Alright, so let's start by comparing what happens in metals and non-metals. So most metals will try to lose electrons. And when this happens, they become positive. So here's lithium, my example. This lithium atom, it has 3 protons. It has 3 electrons. So at the moment, its overall charge is nothing. It's 0. It's got the same amount of positives and negatives. But we can see lithium has 1 electron in its outer shell. So to gain a full outer shell, to have a full outer shell, the easiest way the easiest thing to do is essentially going to be losing this electron. Alright, it's going to be easier to lose 1 electron than it is to try and gain 7. So lithium basically will try to lose that electron. So here we've got the lithium ion. Lithium has now lost that electron. And if it's lost that electron, you can see here it's got 2 electrons now and 3 protons. So it's an uneven number. And down the bottom here you can see, well, we've got 3 pluses and 2 minuses. So the overall, if we cancel that out, so basically here 1 plus 1 minus, so those cancel out, another plus, another minus, those cancel out. I've still got a plus left over because we lost this electron. There was an electron here. Alright, but we've lost that electron, so we've got 1 plus left over. So overall, the lithium ion is positive 1, or plus. So we write it as Li plus, lithium plus. So let's have a look at a nonmetal. So most nonmetals will try to gain electrons. And this basically, when this happens, they become negative. So fluorine, here, you can see if we look at the outer shell, it has 7 electrons in its outer shell. There's 1 unpaired electron over here. But however, fluorine, it starts with a fluorine atom, has the same number of protons as electrons, as shown by the little pluses and minuses underneath the diagram. But when fluorine gains an electron, so fluorine will try to gain an electron to have a full outer shell, have 8 electrons in that valence shell, it now has gained an extra electron, so that means we've got here 1 more minus than we have pluses. So it becomes a fluorine minus ion. Now there's one thing that students often get wrong here or do poorly, and that's just the idea that students often think, hey, if it's gaining an electron, it should be positive. You've got to remember, electrons are negative. Electrons are negative. If I gain negativity, I become more negative. So I gain electrons, I become more negative. Alright? I lose electrons, I become more positive. So just going back to the metals, non-metals idea, I often use this analogy that it's the guys who are the metals and it's the girls who are the non-metals. And there's a few reasons for that analogy. One, when we look at compounds, when they join together, the naming, traditionally it's often the males or the guy's name who goes first. And when they get married, so when a metal and a non-metal partner up, when a guy and a girl get married, it's traditionally the woman's name whose name changes. And it's the same here. If we have lithium and fluorine come together, it would be lithium fluoride. So the metal, the guy's name goes first, and the girl's name goes second, and the ending, the last part of her name, changes. So I often call these Ionic marriages. The girls get their revenge though, because you can see here, it's the guys who are always the losers. They're the ones who always lose electrons. Where it's the girls who are always the winners. They're the ones who always gain electrons. I guess, guys, that's just what they do to us, huh? Alright, so guys, what is an ionic bond? Well, an ionic bond is just a chemical bond. It's the attractive force between two atoms. And in this case, if we have lithium has lost an electron and fluorine has gained an electron, lithium now becomes positive, lithium plus, fluorine is now fluorine minus, and that means that now those opposite charges means that they'll be attracted to each other. So it is literally that once one's lost an electron, the other one's gained an electron, overall one is now positive, one's now negative, opposites attract, and so there's an attractive force between them which holds them close together, and that's your chemical bond. So this is what we would refer to as an ionic bonding diagram. And so if you were asked to draw a diagram showing the bonding between lithium and fluorine, basically we just want you to draw a diagram, usually Bohr diagrams showing the electrons, showing what's happened, that an electron has moved from the metal to the non-metal, and that the resulting atoms have actually become ions, that one is now positive. Metals always form positive ions, whereas the non-metals always form the negative ions. So you can see here, guys, an ionic bond is the resulting attractive force between ions, those opposite charges. So the metal here, sodium for instance, and chlorine, showing that attraction, those opposite charges being attracted to each other. Now I thought I'd just do one more example. So if we do an atom, what should we pick? Maybe beryllium. So beryllium is number 4 on the periodic table. So it's atomic number 4. So beryllium has 4 electrons. So let's get rid of that 4. If I give beryllium its 4 electrons, it'll have 2 in the first shell and 2 in the second shell. Alright, so the easiest way for beryllium to gain a full outer shell, remember the first shell is full when it has 2, is actually to lose these 2 outer electrons. It's going to be easier than trying to gain 6 electrons. So essentially, beryllium will lose those electrons, and when it does, it will have just the 2 electrons. So if it's lost 2 electrons, now remember electrons are minus, it's lost negativity, it's going to be less negative. Being less negative means it's more positive. So losing electrons, losing negativity makes it more positive, and because it's lost 2, we now say it's beryllium 2+. So that's the ion. So this is beryllium the atom. This is beryllium, it's lost those 2 electrons, so overall it must have more protons than electrons now. It's going to be overall 2+. So guys, I hope that helped. There's lots of examples that we could do or you could look at. You could try doing maybe the first 20 elements. You'll notice, and that's no coincidence, that all of the ones in group 1, so the first column, all have 1 spare electron, they all form 1+ ions. Group 2 all have 2 valence electrons, they all form 2+ ions. Alright, through to on the other end, group 7, or sometimes it's referred to as group 17, the second to last one, they all have 7 valence electrons, so they just need to gain 1 more electron, they all make 1- ions, so that you can see those trends in the periodic table. But just remember, please remember, because lots of students make mistakes with that, if I lose electrons, I become positive. If I gain electrons, I'm becoming more negative. Cool. Okay, guys, I hope that helped.